Hey, what's up, Chem peeps? In this video, we're still talking about where those electrons are at in the electron cloud. Now, though, we're going to focus on the valence electrons and express where those electrons are at in what are called Lewis valence electron dot structures. Let's do this. So, first, a Lewis valence electron dot structure, in the name itself, talks about and focuses on just the number of valence electrons. We're also going to get the symbol for the element for which we're working with. A couple of things. Valence electrons are those electrons in the outermost energy level of an atom. Why are we focusing on those guys? Well, turns out that valence electrons, they're the ones responsible for determining how an atom will chemically react with other atoms. They're really important. And so these types of configurations really highlights the importance of those valence electrons. Now, here are a few steps, and then I'll show you how to do some. As you think about drawing a Lewis valence electron dot structure, first thing you're going to do is write the element symbol down on your paper. Next, determine the group number that element is in, that vertical column, that family. The reason why we're doing that is because that group number will tell you the number of valence electrons. It's just a little shortcut to coming up with the answer to the number of valence electrons. Next, start on the right of your element symbol and moving counterclockwise, put a dot every 90 degrees until the number of valence electrons present in the atom is achieved, based on that group number. Now, super important, you do not have to start on the right, and you don't have to move every 90 degrees. As long as you get the correct number of valence electrons around your symbol, you'll be good to go. Lastly, we will learn that neutral elements will gain or lose electrons to form charged ions in order to complete their valence level. We'll talk more about this, but in general, metals will lose electrons and form positive ions, and nonmetals will gain electrons to form negative ions. Again, the goal is to complete their valence level, and we'll talk more about why they do that in later units. Okay, so quick review on groups. Again, we're talking about the vertical columns, and they will be the key to determine the number of valence electrons that you're going to represent in your Lewis valence electron dot structure. So as you take a look at the periodic table on your screen now, group 1, 1 electron, group 2, 2 electrons, and as you move through, those continue with your main group elements, 3, 4, 5, 6, 7, and 8. Be careful, helium over there, even though it's in group 8, it only has 2 valence electrons. All right, so here's some examples. We're going to take a look at carbon, right? It has 6 total electrons, but notice in group 4, only 4 of them will be in the valence level, which will be the second level, right? Remember, the period or row tells you the energy level. So there's 4, 1, 2, 3, 4 valence electrons. What does the structure look like? Well, there's my symbol. Now I'm just going to put a dot and move around carbon until I've got 4. Again, keep in mind that if you don't use this particular format, that's okay. Just make sure you've got a total of 4 valence electrons around carbon. Let's try another one. How about my good friend hydrogen, right? It's in there, group 1, only 1 valence electron. Easy enough. Write the symbol. Boom, 1 valence electron. One more example, phosphorus. Dang, phosphorus has 15 total electrons, but notice its group is group 5, which means of the 15, only 5 are in the valence or outermost level. And so when I write the Lewis valence electron dot structure, 1, 2, 3, 4, 5, boom. Again, I encourage you to use this format, but as long as you got 5 at the end, you're good to go.